Hello and welcome, dear students, to today's session on business mathematics, statistics and logical reasoning. Today we come to the last session of business mathematics and we shall be taking up integral calculus. In the last session we had detailed discussion on differential calculus, and you may remember that we had discussed about the concept of differential calculus and the fact that differential calculus deals with changes in y, where y is the dependent function, due to small changes in x, which is the independent function, and we discussed number of problems of differential calculus. Today, first we are taking up the basic concept of integral calculus, which is, you can say, the opposite of differential calculus. So in case of differential calculus, we were talking about dy by dx or delta y by delta x, but today it is the reverse, right? And therefore we will use integral. The sign is this, integral calculus. We shall look at the concept of integral calculus, and then we will also see why integral calculus is sometimes referred to as antiderivative. Antiderivative because in case of integral calculus, we are integrating, we are summing up, right? And if you see this sign, the sign of integral calculus, it is nothing but s. If you elongate s, if you elongate like this, then it becomes like this, and then finally it becomes like this. So integral calculus is nothing but a way of summation. And we have lots of formula for integral calculus. We have some standard results. We shall be discussing each of them, and I shall be writing one after the other the standard formula, which are very, very important from the exam point of view. And as I have already discussed, differential calculus and integral calculus is an important part of our exam syllabus. And at least 2 to 3 examples, 2 to 3 questions definitely can be expected from this important chapter, right? And all the formula will be written one after the other, which are relevant for the exam, and the major formula I'll be discussing. And we will also go into a unique part of integral calculus, and that is integration by parts. So after we discuss the important formula, we shall also discuss integration by parts. And there is another specific technique of integration function, and that is partial fractions, which I will be discussing. And we shall thereafter move into definite integration. There are 2 types of integration, indefinite integration and definite integration. So we will go into definite integrals, and we will also solve number of problems from exercise 8b. Exercise 8b of the study material, which deals with integral calculus. So this is the game plan for today, and once again, this is the last class on business mathematics, and next day onwards we shall move to the logical reasoning part of our exam syllabus. Now first is dy by dx, we discussed, is known as the derivative of the function y, and you see that delta y by delta x or dy by dx is a way of doing what? Of differentiating. That means we are finding the derivative of a particular function using differential calculus. So differential calculus breaks down, it disintegrates. So small change in x, as a result of which, what is the corresponding change in y? This was the basic point of differential calculus. But in case of integral calculus, it is just the reverse, and we shall be discussing how integration takes place, and this symbol is used, which is also the symbol for summation. So please note the first point, that in case of integral calculus, it deals with summation. So we have s, and this s, when elongated in a stylish way, if you write s, this becomes the symbol of integral calculus. I have written the same symbol here and here as well. So it is like elongated s, and in other words, this is the symbol of summation. Secondly, integral calculus is also known as anti-derivative because it does the exact opposite of derivative in case of differential calculus. In case of derivatives, we were trying to find out small changes in y, function y, because y is a function of x, small changes in y as a result of small changes in x. But here we will try to integrate small parts together into a bigger part. Okay, so it is just the opposite of differential calculus, and therefore whatever formula we have learned in the last day about differential calculus, here, for example, we had a formula, you remember, x to the power n ddx of this. So the formula, if you remember, was n into x to the power n minus 1. So this time, when you integrate this part, if you integrate nx n minus 1 dx, you will be getting x to the power n. So it is just the opposite way, and therefore the formula which are used for differential calculus is opposite to the formula which will be used for integral calculus. Of course, there will be exceptions, but by and large, integration can be said to be the opposite process of the reverse. So I would write the words reverse and opposite so that you can understand that it is nothing but the opposite process. So you can call it inverse, you can call it reverse, or you can call it opposite, right? The opposite function or the opposite process of differential calculus is integral calculus, and that is why it is sometimes referred to as anti-derivative. You know, anti means against, anti means opposite. Okay, so it is just the opposite of differential calculus. And in general, if you see the way we write integral calculus, for example, I want to write, say for example, the integration of fx. So I will write like this. This is the symbol of integration, fx dx. That means I am integrating the function fx dx. And integration, as you can see, is summing together, integrating together, right? And therefore, the idea is to ultimately sum up small parts into the main function. So here we are trying to sum up individual small portions of a function into a combined function. Right, so that is the entire objective of integral calculus. Initially, integral calculus, if you see long back when integral calculus was first introduced by, the celebrities of physics, science, that is Sir Isaac Newton and Leibniz, both of them independently introduced calculus. They discovered calculus, and initially the idea was to add together infinitesimal small portions. Infinitesimal, which means very small portions. The idea was to add them, the idea was to sum them up, the idea was to integrate them, and that is how integral calculus came. Now, second point is, what is the use of integral calculus? Now, last day, you may remember, we discussed a lot and I solved a number of problems on the applications of differential calculus. So, differential calculus is not just used in science or in physics, but it is also used in economics and finance. The moment you open any study material in finance or in economics, you will find that these deal with differential concepts. These deal with differential calculus, because rate of change, whenever I discuss about rate of change, we have to refer to differential calculus. Similarly, in case of integral calculus, there are a number of applications. For example, the total number of customers added in a company during a period of time. The function is given, so you may have to integrate. Profit of a company down the years, totaling up the profit of a company, when the profit function is given, when the revenue function is given, right? You may remember last day we took revenue function, cost function, profit function. Same thing, even in integral calculus, if you are given the profit function or if you are given the rate of change in profit, for example, you can find out the original function by integration. Similarly, in audit, when we compute total audit risk, when we carry out sampling, there also we have applications of calculus, precisely speaking, integral calculus. And of course, in geometry, when we want to find the area of a curve, for example, in definite integration, say we have x-axis, y-axis, and there is a curve like this. Okay, so this is 0. So if you want to find the area of the curve, I am showing it by the shaded portion. If you want to find out the area of this curve, yes, we use integral calculus, and this concept is important for us because we have a portion in our syllabus which is called definite integration, and the word definite integration means that I am trying to find out the total area under a curve, say between the points x equal to 2 and x equal to 7. So between the points x equal to 2, which is this line, and x equal to 7, which is this line, the total area which you see, the total area between the x-axis and the curve can be computed using the principles of integral calculus. So both functions, relations, as well as differential calculus and integral calculus has practical applications in the world of business, in the world of audit, in the world of finance. That means these are highly relevant for chartered accountants, and therefore it is included in our syllabus. Okay. So now we can say that integral calculus can be said to be an antiderivative. You can call it an antiderivative because it is the opposite of finding a derivative. Instead of dividing and differentiating, we are combining, we are summarizing, we are summing up, we are integrating. Okay? So therefore, dear students, you can see it is often called or often referred to as an antiderivative. It has an inverse relation to differentiation, and the process of integration can be said to be a reverse or an opposite process to derivatives. Okay. I also discussed about how we write derivatives last day. Today I discussed about how we write integration concepts. So fx dx. So if you want to integrate, we use this integration sign. Plus this small picture, this small diagram shows you how we use definite integration to find out the area of a curve between two given points, say x equal to 2 and x equal to 7 in this example. Okay. Now we shall see some of the important rules for integration, and you will find that these are quite common to differentiation because here in case of integration, it will just be the reverse of what we did in case of differentiation. Of course, at this point, at this stage, we should discuss a little bit about the difference between definite integration and indefinite integration. Now, if I write fx dx and if I write fx dx between 1 and 2, what is the difference between these two expressions? The first one is only fx dx. That means we are trying to integrate the function fx. That means a very small part of fx function, which is fx dx, we are trying to integrate that. So this type of integration, please note that the two ends, we have no numbers in the two ends of the integration sign. This type of integration is known as indefinite integration. Indefinite. So this is indefinite. Why indefinite? Because we don't have the lower limit and the upper limit. We don't have the two ends, the two limits. But here, fx dx, please note that we are having two numbers, 1 and 2. It can be any number. It can be 0 and 10 also. Any number. In other words, the lower part of the sign, if you look at this sign, integration sign, in the lower part of the integration sign, we have a number which is called the lower limit, and we have another number at the top which is called the upper limit. That means in this case, we are trying to find the integration. We are doing the integration of this given expression, but there are two limits, 1 and 2. So we shall find out the integration figure and find out for x equal to 1, what will be the amount, for x equal to 2, what will be the amount, and therefore what we shall do is, after we integrate, we will do f of 2 minus f of 1. That means we shall find out function putting x equal to 2, and from there we shall also find out the amount of the function when f equal to 1, x equal to 1. So f2 minus f1, that is, we will find out two values of the function, one where x equal to 1 and one where x equal to 2, and the difference, this difference or this way of depicting a particular integration is called definite integration. So this is the concept of definite integration. So whenever you have two limits, lower limit and upper limit, whenever you see that the problem in the exam contains two limits, please note that it will be a case of definite integration, and this particular expression, when you don't have any numbers at the two ends of the integration sign, then it is a case of indefinite integration. Definite integration is used, again, I just drew a picture, small diagram of a curve. Whenever you want to find out the area of a curve, okay, the area of a curve, then we use definite integration because we have to define. Area means you have to tell what is the area between 2 points. The area bounded by 2 points. Bounded by 2 points. So you have to talk about lower limit and upper limit. That means definite integration will be used in such case. But wherever we don't have any numbers at the two ends of the integration sign, it means it is a case of indefinite integration. Right? I hope, dear students, you must have understood the difference between indefinite integration and definite integration. We proceed now to look at the basic formula, and we shall be following the study material very closely like we do in case of all chapters. So I request you to bring out section 8b2. Okay, so let us look at the formula now. So I'll be rubbing this portion, and we shall be now concentrating on understanding the different formula which we use for integration. The first formula, so this is 8b2. 8b2. The first formula we are discussing is something which we learned also in case of, you may remember, in case of differential calculus also, and this is the power function, right? So we will start with this, and I will be writing the important formula here. We will be explaining this. I will be taking examples in this part, and then I will be referring to the formula here. Now, the first one we take up is what happens when we have to integrate x to the power n dx. The first formula, x to the power n, integration of x to the power n dx. Now it's a standard formula, and the formula is x to the power n plus 1 by n plus 1. Now please remember, in case of differential calculus, it was totally different. X to the power n, the differential coefficient was n x to the power n minus 1, but here it is x to the power n plus 1 divided by n plus 1. Now in integral calculus, there is a concept of constant of integration. So after we find this out, we have to add a constant. The constant can be referred as K or it can be referred as C also. So the letter K or the letter C stands for the constant of integration. And for every question which comes on integral calculus, especially those questions on indefinite integral, please remember, in case of indefinite integral, you have to add the constant of integration. Otherwise, the answer will be wrong in the exam. So please remember, in the exam, when a question comes on indefinite integral, please remember to add the constant of integration at the end. So after you find out, so x and dx integration is x to the power n plus 1 divided by n plus 1 plus constant. You can take C as a constant or you can take K as a constant, whatever, but you must indicate, it must be clearly mentioned that it is a constant of integration. You must know this, that K or C stands for the constant of integration. The question is, why constant of integration is used? I'll take an example. Say, if I take the expression, say for example, x to the power 4 plus 5. Okay. Now if you differentiate this, the answer will be, if y equal to this, and if you want to find out the differential coefficient of this particular function. So what will be the dy dx? dy by dx will be equal to 4x cubed plus 0. Because 5 differential coefficient is 0. Now the question is, if I ask you that this is the differential coefficient, which means dy is equal to 4x cubed dx. This dx comes here. So if I tell you that y equal to x to the power 4 plus 5 is a function, it's a function, fine. It's a function. So if you differentiate both the sides, we are having dy by dx, which is equal to 4 into x cubed. Because x to the power 4, the differential coefficient is 4x cubed. Plus 0, because we know that differential coefficient of a constant is 0. So we get dy equal to 4x cubed. Now if I ask you to integrate this side, the right hand side, what will happen? If I ask you to integrate 4x cubed by 4x cubed dx, then your natural answer will be 4 will come out, 4 is outside, x cubed. So the formula is x to the power n dx becomes x to the power n plus 1 by n plus 1. So in case of x cubed, it will become 4 into x to the power 4 by 4. So 4 and 4 cancels out. You get back x to the power 4. Please note, you get back x to the power 4. This x to the power 4 you have got back. But something is missing. I started with x to the power 4 plus 5. Very good. I differentiated both the sides. So I got dy by dx equal to 4x cubed plus 0. Great. So now, when I integrate 4x cubed dx back, I am getting only x to the power 4. But where is this 5 going to go? That is why, dear students, we add the constant of integration. So the answer will be x to the power 4 plus c. So that the constant of integration is added, and therefore we know that yes, x to the power 4 was not the only term. There may be another constant after this. That is the reason why we add the constant of integration. Always please remember that the constant of integration, either it is k or c, or it can be other numbers also, other letters also. This is used in case of indefinite integration. The constant of integration has to be added after you carry out indefinite integration. So the first formula we will note so that we don't forget, that is, we have done x to the power n dx. Now we go to the next formula. Formula number 2. Now what happens when, in fact, the formula number 2 I've just done using this example. Now the question is, what will happen if the expression is like this? Say k into fx dx. So there's a function fx dx multiplied by k, which is a constant. So what will happen to this type of integration? Very simple. K will come out. So this will be equal to k outside fx dx. Okay. So if I take an example, say it is 5x cubed dx. 5x cubed dx. 5 is a constant, so this means 5 will come out, you will have x cubed dx. Right? So this is called the constant multiplier rule. Constant multiplier rule. The first one which you see is known as the power rule. It is the power rule, and the next problem, the next function or the next formula which we see is called the constant multiplier rule, because in case of a constant, when you multiply a function, here I have multiplied this function by a constant k, so the constant will come out and we will only integrate fx dx. So this is the second formula, and I am writing here the second formula so that we can refer to the formula later. K into fx dx. Okay. Now we proceed to the third formula, and that is very similar to the one we did in case of differentiation. The same formula, that is addition and subtraction of functions in case of integration. So formula number 3 in front of you, we are integrating two functions. So we are having fx plus gx dx. So here we have two functions, fx and gx. Okay, they are functions of x. Two different functions of x, and we have added them. So now the addition rule says that in case where two functions are added together and you have to find the integration, you have to carry out the integration. The process is very simple. It is the same as we did in case of differential calculus. Here you add it separately. That means it will be like this. It will be integration of, first you take fx dx. So the first function is fx dx plus, second we will take gx dx. That means a sum of two functions, fx and gx, when it needs to be integrated, you can integrate them separately, fx dx separately plus gx dx separately. So this is the addition rule. We are noting the addition rule here. Fine. Now we shall take up what is called the subtraction rule. The subtraction rule will be the same, no change. So instead of plus sign, I just write here minus, and here again in case of plus sign, it will be minus. That means fx minus gx. If you want to find the entire, if you want to integrate this entire function, fx minus gx, then the best way to do it, the recommended way to do it is carry out integration of fx dx first minus integration of gx dx. Okay, we will take number of examples. So let's first focus on the formula. We keep noting the formula and then we will see at least 40 to 50 examples. Not to worry on that. Right. So fx minus gx will be integration of fx dx minus integration of gx dx. Now let's take few examples. So this is the subtraction rule. So we have done the power rule, number 1. We have done the constant multiplier rule, the addition rule, and now we have done the subtraction rule also. the rule of subtraction. Okay, 1, 2, 3, 4. Next we move on to an example. Let us take this example. Let's take, say, easy one first. So let us take only dx. What will be the answer? Integration of dx is equal to x. But don't forget the constant, so x plus k. Integration of dx is only x. Right? The first one. Next one we take is, let's take 4x dx. So we have 4x dx. We want to integrate. So we use the constant multiplier rule, 4x dx. 4 comes out, so it becomes 4x dx. But we know x dx means it is of the form power rule. It is of the form power rule. And power rule says that x to the power n dx will be x to the power n plus 1 divided by n plus 1. So in this case, it will be 4 into x to the power 1 plus 1 divided by 1 plus 1. Because you know x means x to the power 1. So x to the power 1 plus 1 divided by 1 plus 1. So if you simplify, it becomes 4 into x squared by 2, that is, the answer is 2x squared. Okay? But we cannot forget the constant of integration, so I add plus k. Okay? So this is, we are taking two examples, dx becomes x plus k, and integration of 4x dx becomes 2x squared plus k. The process is just reverse of what we did in case of differential calculus. And the power rule is just a mirror image. It is a symmetric image, right? In the case of differential calculus, we were reducing it. Here we are adding by 1, n plus 1. That's the only difference. Otherwise, it's just a case of pure symmetry, right? It's a mirror image. When you consider differential and integral calculus, it is just a mirror image. Okay, now let us look at some more examples. So now we will take up the integration of another expression, and that is 12x cubed. So integration of 12x cubed. Okay. So we have to use the power rule, and therefore we are also using the constant multiplier rule, because we can see there is a constant 12. Please see the numerical, and again I would request you as usual to practice with me. So you must have your pen and paper ready, and please take as much of examples as possible so that you have complete clarity on this particular chapter. Definitely being the last chapter, differential calculus and integral calculus is comparatively more difficult than the earlier chapters, and you need to have a good command over this chapter as well, because questions are going to come from this chapter also, and there are two parts to it, differential and integral. Within integral calculus, we have further two divisions. You have indefinite integrals and you have definite integrals. Questions can come from any portion, right? So we should be thoroughly prepared to face any questions, and that is the reason why the more you practice with me, the more it becomes clear to you. So 12x cubed dx. We use the power rule, and we also use the constant multiplier rule. What I do is I bring out 12 here, so it becomes 12x cubed dx. X cubed dx is of the form x to the power n, so the formula will be 12 into x to the power 3 plus 1 by 3 plus 1 plus the constant k. Okay, so this is the process. Therefore, this one, when simplified, becomes 12 into x to the power 4 by 4. So it becomes 3 into x to the power 4 plus k. 3 into x to the power 4. 3x to the power 4 plus k. Right? If you quickly differentiate this, you will get back again. You will be getting back 3x4. If you differentiate, you will get back 12x cubed. So it's just a cycle. Okay, from this point to this point, differential. Again, from this point back to this point is the integration. So it completes a cycle. Completes a cycle. Step 1 is this. Step 2 is from here to here. Okay, right. Now we will take up another example, and the more we do, the more, of course, it becomes easy for us. Let me request you to take up this one. X cube dx. Okay, it's already done, but still, x cube dx. If you have x cube dx, so instead of 12, you only have x cube. X cube dx. What will be the answer? X cube dx will be x to the power 3 plus 1 by 3 plus 1. So x to the power 4 by 4 plus constant k. So x to the power n plus 1 by n plus 1. Now we take another one, and this time the expression is addition rule we are using now. So we have done the power rule, we have done the constant multiplier rule, addition rule and subtraction rule, and we are now dealing with different examples. So now the example is 3 x to the power minus 2 plus 4 dx. 3 into x to the power minus 2 plus 4 dx. So dear students, this is an example of an addition rule. There are two parts to it. So we will take it separately as per the addition rule, and therefore we first take 3x to the power minus 2 dx plus 4 dx. 4 comes out. Here again 3 will come out. So we have 3 into x to the power minus 2 dx plus 4 dx. We have seen that only dx, integration of dx is what? X. So this becomes 4x. And this one becomes 3 into x to the power minus 2. So we use the power function rule. The power function rule says that x to the power n dx is equal to x to the power n plus 1 divided by n plus 1. So here we have x to the power minus 2. That means n is minus 2. N is equal to minus 2. So n plus 1 will be minus 2 plus 1. Here in the denominator also it will be minus 2 plus 1. Plus, as usual, we have 4x. So we are getting 3x to the power minus 2 plus 1. So this becomes 3 into x to the power minus 1. And here again we have minus 2 plus 1, that is minus 1. So we get minus 3x to the power minus 1 plus 4x. This becomes minus 3 by x plus 4x. But we cannot forget the constant of integration, so we write plus c. Okay, so in this case we used the addition formula because we have two expressions. So we are integrating 3x to the power minus 2 dx first, and then we are integrating 4 dx. Okay, 4 dx means we use the constant multiplier rule. We bring out the 4 outside the integration sign, and now we use 3 into x to the power minus 2 dx. So in this case we use the power function rule, and it becomes x to the power minus 2 plus 1 divided by minus 2 plus 1 plus this 4 dx becomes 4x. And the rest is naturally following using simplification of the given expression. So please don't forget the constant of integration. And secondly, we did that what will be the integration of only dx, and the answer is x plus k. X is the answer plus the constant of integration. Okay. Now we'll take another one. Let's take 3x squared. Okay. So let's take the next expression, 3x squared dx. So 3x squared dx. Simple. Bring out 3. You have x squared dx. X squared dx is of the form x to the power n So this will become 3 into x to the power 2 plus 1 by 2 plus 1 plus the constant k. So this is equal to 3 divided by 3 into x to the power 3 plus the constant k. 3 cancels out. So you have x cubed plus k. Please check. I'm sure you are following and you are also doing with me the numericals, and you are arriving at the same results. We are dealing with the easy ones to build up the confidence. As I said, these two chapters are not to be taken lightly. Many people have difficulty in understanding the chapters. There are a number of doubts which people have, but the more we practice the easier ones, you will be able to move to the difficult ones without any lack of confidence. You will be able to have your full confidence, comfort, self-belief, and you shall be able to deal with the difficult ones also. Right. So this is 3x squared dx. We have integrated successfully. Now we carry on and we are going to take up the next formula. Okay. What happens? So this will be 1, 2, 3, 4. The fifth formula. The fifth formula is, please note, is k into x to the power n dx, where k is a constant. Okay, so we are having k into x to the power n dx, where k is a constant. The result will be, if you see the result of this expression, will be k into x to the power n plus 1. X to the power n plus 1 divided by n plus 1 plus c, the constant of integration. So this is a case where you have, apart from x to the power n, you also have k. Now k will go outside x to the power n plus 1 by n plus 1. Okay, which we did. So this is a standard formula. Also please remember that there is another formula for the expression dx by x. In other words, if you get an expression like this, 1 by x dx, that is dx by x. Okay? So this will be equal to log x to the base e plus the constant k. So please note these two formula also. There are a number of formula which we will be doing in integral calculus, almost 10 to 12 of them, one by one. Slowly we are doing, so that we have full 2 hours, almost 1 hour, 15-20 minutes are left, so we can take time and do and make sure we understand each and every step. So k into x to the power n, I think this is clear. The next one is dx by x, integration of dx by x. Or if you get 1 by x dx, or if you get x to the power minus 1 dx. So x to the power minus 1 dx directly will give us log x to the base e. Please remember that log x to the base e is sometimes, the base is e, the base is not 10, the base is e. You may remember that last day I discussed about the letter e. E is an exponential constant. Roughly 2.718 is the value. E is equal to this. So this is sometimes written as ln, logarithm and natural, ln x plus k. Okay, so this is the base of the natural logarithm. Okay, so this is, again, these are two important formula which we have done. So dx by x we have done equal to log x to the base e, and we have also done kx and dx. Okay. We proceed to the next functions. Now we have, fx. Let's take some other functions and see what are the other additional formula to be learned. So fx equal to x we have done if fx is x. If x dx, this is x squared by 2 plus k. X to the power 1, so it becomes x to the power 1 plus 1 divided by 1 plus 1 plus k. if it is, say, if it is x square, if it becomes x square dx, then it will be x to the power 2 plus 1 by 2 plus 1 plus k. That is, it becomes x cubed by 3 plus k. Similarly, if fx is dx by x, then it becomes log x to the base e plus k. Okay. Let me take some more examples. X to the power 7, you have to do integration of x to the power 7 dx. So x to the power 7 means the same formula, x to the power 7 plus 1 by 7 plus 1 plus k. That means x to the power 8 divided by 8 plus the constant k. Okay. Now some more examples. We will take some negative power now. Some negative power. And I take up this one. 2 divided by u square du. Integration of 2 divided by u square. 2 divided by u square du. Okay. So here we have a negative u to the power minus 2. So this becomes 2 into u to the power minus 2 du. Using the constant multiplier rule, 2 comes out. So we get 2 comes out, u to the power minus 2 du. U to the power minus 2 is of the form x to the power n. Of course, here n is negative. It can always be negative or positive. No problem. So here it becomes 2 u to the power minus 2 plus 1, because the formula is n plus 1 divided by n plus 1. So again minus 2 plus 1. But we cannot forget the constant, so plus constant c. This becomes 2 into u to the power minus 1 by minus 2 plus 1, that is minus 1, plus c. So it becomes minus 2 by u plus c. Minus 2 by u plus c. So we took 2 into u to the power minus 2. Another way of expressing 2 by u square du. So 2 into u to the power minus 2. 2 comes out. U to the power minus 2 du. U to the power minus 2 is of the form x to the power n. So we use the formula x to the power n plus 1 divided by n plus 1 plus the constant c. This becomes minus 2 plus 1 is minus 1. So you have 2 into u to the power minus 1 divided by minus 2 plus 1 minus 1 plus the constant c. So this translates to minus 2 by u plus c. Okay. So this is this particular example, the solution to this particular integration problem. Okay. Many of these have come in the exams. I have taken a lot of problems here which came in the exam. Okay. Now we go to the next one, and this will be the next formula. This is what happens to this one, e to the power x dx. E to the power x dx. Don't have to remember. This is very easy. It will remain e to the power x plus c, of course. So e to the power x integration will be the same, because you may kindly remember that in the differential session, we had the session on differential calculus in the last day. We did the differential coefficient of e to the power x and e to the power x. So if you do d dx of e to the power x, it will be e to the power x only, no change. So if you integrate e to the power x, you will get back e to the power x only. So no change. So very simple formula, e to the power x we have done. Now question is, what happens when a slight complication comes? What happens when we add e to the power kx? So we are taking e to the power kx now. What happens when it is e to the power kx? Where k is a constant, e is a constant, k is a constant, x is variable. Okay? So the formula will be e to the power kx by k. So e to the power kx, e to the power kx by k plus the constant of integration c. So please note this as well, e to the power kx formula. So these formula you have to memorize. That is why I repeatedly request you to practice as much as possible. The best way to get high marks in your exam is to practice. Memorizing is important, but only memorizing will not help you in the exam, because you need to also build up your speed, your confidence, which is only possible when you do a good number of problems, when you solve them under exam conditions. So e to the power kx is done. Now we take the next one, important formula, and that is a to the power x. Okay? So we take a to the power x dx. A is a constant. So the solution to this, the formula is a to the power x by log of a to the base e plus constant c. Okay? So this is a to the power x dx. The formula is a to the power x divided by log a to the e. So as you know, log e to the base e means it is natural logarithm, and often it is written as ln a. Okay, ln. ln stands for logarithm natural. ln a. Okay, so we have done a to the power x dx. Now we add one more complexity to this. The formula for a to the power kx dx. A to the power kx dx. So we started with the power function x to the power n dx. Then we did the constant multiplier function where we had k into fx dx. Then we completed the addition function. Okay, the addition of two functions. Thereafter, I solved questions on the addition and the subtraction function. What happens when there are additions or subtractions? Then we had the dx by x, which is log x. Then we had k to the power k into x to the power n. Then we had e to the power x, e to the power kx, a to the power x, and now we have a to the power kx dx. Integration of a to the power kx dx. So this will be a to the power kx as it is. It will come here, but divided by k into log a to the base e plus c. So a to the power kx dx will be equal to a to the power kx by k. This k comes down. The k which you see in the index, in the power, k is in the power, kx, k comes down. A becomes log a, but this is a natural log to the base e. Okay, plus the constant of integration c. So these three are very important formula, and I would request you to add it in your notebook as well. So we have done a to the power kx dx. Okay. We now proceed to see some more examples. So we do the formula, we note them, we also see examples, solve it together and proceed. Now I am taking up square root function. X, square root of x dx. What to do? So it is a square root function. Please remember that square root of x means x to the power half. Okay, so I can rewrite this expression as integration of x to the power half dx. X to the power half dx. Now x to the power half. This expression is of the form x to the power n. And we know that the formula is x to the power n divided by n plus 1. Okay, so you know the formula x to the power n dx is equal to x to the power n plus 1 divided by n plus 1 plus, of course, the constant of integration c. So in this case, it will become x to the power half plus 1, n plus 1. So half plus 1 divided by again half plus 1 and we have the constant of integration, c or k, whatever you can add. So therefore, dear students, it becomes x to the power 3 by 2. X to the power 3 by 2. In the denominator, it becomes 3 by 2. So when you change it, it becomes 2 by 3. So it becomes 2 by 3. 2 by 3, x to the power 3 by 2 plus constant of integration c. So let's take or just have a look at this expression, how we have solved it. X to the power half dx, x to the power half because it's a square root, so it becomes x to the power half dx, right? And this actually is of the form x to the power n, and this is x to the power n plus 1 divided by n plus 1. So we have used the power function rule, and we have got x to the power half plus 1 by half plus 1, and this ultimately simplifies to 2/3 into x to the power 3 by 2 plus the constant of integration plus c. Okay, so this is the solution to this particular problem. Okay, now we are taking up another small example, and this is a very simple one, of course. We have 6x dx, integration of 6x dx. So using the constant multiplier rule, we can write this as 6x dx. 6 comes out. So it becomes 6x dx. This becomes 6 into x dx. X is having the power 1. X dx means x has the power 1. So using the power rule, we can write this as x to the power 1 plus 1 divided by 1 plus 1 plus the constant c. So this becomes 6 as it is into x squared by 2 plus c. 2 cancels, so this becomes 3x squared plus c. Okay, please have a look at this process and see whether you must be understanding this now. So 6x we have integrated, and the result comes to 3x squared plus c, where c is the constant of integration. Okay, now we proceed to another one. We take again a negative function, a negative index. So we take this one, 2x to the power minus 3. So integration of 2 into x to the power minus 3 dx. Okay, so let us try this one. 2 into x to the power minus 3 dx. 2 into x to the power minus 3. Now, here you can see it is again an application of the constant multiplier rule as well as the power function rule. So what we do is, this is equal to 2 outside x to the power minus 3 dx. But this gives us x to the power n rule. So minus 3 plus 1. In the denominator also we have minus 3 plus 1 plus the constant of integration. So this becomes 2 into x to the power minus 2, and this becomes minus 2 again, minus 2 plus c. So this cancels, it becomes minus. The answer is minus x to the power minus 2 plus c. Okay. This is how we deal with a situation where you have power, but the power is negative, d equal to minus 3 in this case. Now I am taking up an application of subtraction rule quickly, and then we shall move on to the product rule, which is a little bit complex. So you need to write the solution with me and understand each and every step. Let me first take up this one. X to the power 4 minus 4x cubed dx. X to the power 4 minus 4x cubed dx. Please have a look at the problem. We have to integrate x to the power 4 minus 4x cubed. So what we do is we apply the subtraction rule. The subtraction rule clearly mentions that you have to take the two functions separately, integrate them separately. Okay, so what we do here is we first integrate x to the power 4 dx minus 4x cubed dx. So x to the power 4 dx is of the form x to the power n, x to the power n. So this becomes x to the power 5 by 5 minus 4x cubed dx, 4x cubed dx. So in this case 4 comes out, 4 is outside. This becomes x to the power 3 plus 1 by 3 plus 1. Plus I add the constant. So this becomes x to the power 5 by 5 minus 4 by 4. So this cancels out. So this becomes x to the power 4 plus c. So the answer is x by 5, x to the power 5 by 5, x to the power 5 by 5 minus x to the power 4 plus c. Okay? So I hope you are following and you have understood this step. This is an application of subtraction rule. Okay. I am taking another one on subtraction rule. Okay. Now this is 4x squared minus 2x dx. So we are taking this up. 4x squared minus 2x dx. Very similar questions come in the exam. So here directly we are moving on to the subtraction rule application, and this becomes 4x squared dx minus 2x dx. I hope you understand that in this step I have brought the constant outside, 2 is outside, 4 is outside, and there is a minus sign in between. So this, when simplified, becomes 4 into x squared. So this will become x cubed by 3 minus 2 will remain as it is, x dx. So it will become x squared by 2 plus c. This 2 will cancel with this 2. So we are left with 4x cubed by 3 minus x squared plus c. Okay. I hope you have understood this, and we are just applying the constant multiplier rule as well as the subtraction rule when we are having two functions. 4x squared is a function of x, 2x is another function of x. So you can call them, one of them you can call them fx and the other you can call them gx. So it is fx minus gx. So we have taken fx first and then we have taken gx, and by integrating them using the basic principles, we have arrived at the result, and the solution is 4x cubed by 3 minus x squared plus the constant of integration. Fine. Now I am taking up two small examples further. So I am sure your concept is getting clarified and you are able to follow, and after every formula we are spending time to cover as many problems and solutions as possible. Of course, given our time frame. Now we move on to this one. This is the fifth root of x. So, fifth root of x dx. So what to do with this? The fifth root of x. Okay, please have a look at the problem. Fifth root of x. So this can be, you see, all of you are now having good knowledge of the laws of indices, which you learned in the first day. It is the beginning of our mathematics paper, the first chapter. So using the basic principles, I can write this as x to the power 1 by 5 dx. Now it becomes, it has the same form of x to the power n. So this becomes x to the power 1 by 5 plus 1. In the denominator also 1 by 5 plus 1. So this becomes 1 by 5 plus 1 is 6 by 5. When it goes to the numerator, it becomes 5 by 6. X to the power 1 by 5 plus 1 is 6 by 5. So 6 by 5 plus the constant c. So please have a look at the solution to this one. Fifth root of x, integration of the fifth root of x. This can be rewritten as x to the power 1 by 5. And this gives you x to the power n application, x to the power 1 by 5 plus 1 divided by 1 by 5 plus 1. So this means we are getting 5 by 6 into x to the power 6 by 5 plus the constant of integration, which is c, the constant of integration. Okay, I am taking another example. Okay, now I am taking up, this is again a function. So I am taking up 5t cube minus 8t dt. 5t cube minus 8t dt. So using the subtraction rule and the constant multiplier rule which we have noted here, we are directly integrating them. 5 comes out, you have t cube dt, minus 8 comes out, you have t dt. So this becomes, if this is of the form x to the power n, t cube is of the form x to the power n, and we know x to the power n dx is equal to x to the power n plus 1 divided by n plus 1. So directly applying the results, what do we get? 5 into t to the power 3 plus 1 by 3 plus 1 minus 8 into t to the power 1 plus 1 by 1 plus 1 plus the constant k. Okay, so this simplifies further. 5 by 4 t to the power 4 minus 8 by 2 t square plus k. And 2 cancels with 8, so 2 4s are 8. So we end up by getting 5t to the power 4 by 4 minus 4t square plus k. 5t to the power 4 by 4, 5t to the power 4 by 4 minus 4t square plus k. Okay, so this, I'm sure you have got it, dear students. This is how we break up these two particular expressions. One is this one, 5t cube minus 8t, and the other one which I did just now, that is the fifth root of x. Right. Now I am taking another two small examples. Please note these examples. Many of them are not, directly given in the exercises. I am taking some more questions, and many of these are from the MTP, and some of them are past exam questions. So we are doing some additional problems. So this will definitely help you for your upcoming exams. Okay. Now we are taking up ddx 1 by 3. 1 by 3x dx. 1 by 3x dx. 1 by 3x. So how can you rewrite 1 by 3x dx? So I can remove this 1/3 because 1/3 is a constant. So I can remove 1/3. So I write 1/3 into dx by x. Now dx by x we know is equal to log x. Dx by x we have done. It is equal to log x to the base e. Log x to the base e. Therefore this becomes 1/3 log x to the base e plus constant c. Okay. So please note that dx by x is equal to log x. We have done this. Dx by x equal to log x. You can also write this as you never know. The question paper, you will be getting options. As you know, this paper is entirely MCQ and you will be getting options. Now, one of the option can be like this. Instead of 1/3 log x, they might give you like this. Log x to the power 1/3 to the base e plus c. So if you see 1/3 log x is also equal to log x to the power 1/3. Using the basic principles of logarithms, you can understand that log x to the base e, and if I multiply this by 1/3, it actually means log x to the power 1/3 to the base e. Both are same. So be very careful about the options given in the exam. Please study the options carefully and then select the right answer. Okay, now I am doing the next problem, and this problem is minus 2 e to the power minus half x dx. Okay, please see the problem carefully. Minus 2 into e to the power minus half x, e to the power minus half x dx. So how to simplify this? How do we simplify this expression? How to break it up further? This is very complicated looking. So what we do is, first let's simplify. Step number 1, minus 2 I bring out, because minus 2 is a constant. So I bring out minus 2. So it becomes minus 2 e to the power minus half x dx. Now we know the formula e to the power kx. We have done the formula. So e to the power kx gives you what? E to the power kx by k. So this will become minus 2 as it is, e to the power minus half x will remain as it is, but in the denominator we will have minus half plus c. So e to the power kx by k, e to the power kx by k, right? So therefore when you simplify this further, you will be getting minus 2 as it is, minus half. When it comes up, it becomes minus 2 here. So minus 2 into e to the power minus half x plus c. So minus 2 into minus 2 gives you 4. So you get the final answer 4 into e to the power minus half x plus c. 4 into e to the power minus half x plus c. Okay, so this is how we have simplified this. We have first used the constant multiplier rule to bring out minus 2 outside, e to the power kx, and then we have just gone into the solution directly. I am taking up the next problem, and let us solve this as well. 4x to the power 5, so 4x to the power 5 minus 3x plus 3 divided by x. So this is divided by x dx. Okay, so please have a look at the problem. 4 into x to the power 5 minus 3x plus 3 divided by x dx. Fine. So let us try and solve. Okay, so let us try and solve this. Now, how do we solve this? We have x here. So any idea how to solve this? So let us break it up. Let us split and see what happens. So what I do is, okay, let me do one thing. Okay. So let us split it up into this 4x5 by x dx minus 3 into x by x dx plus 3 by x dx. So we are splitting. We have split it into parts. Using the addition and the subtraction rule which we have learned today, we are splitting this and we are getting 4x5 by x minus 3x by x dx plus 3 by x dx. So students, I hope that you are clear with this particular step. No confusion. Okay, no doubts. So therefore, we go directly. So we are getting 4 will come out. So x to the power 5 by x. This gives me x to the power 4 dx. Minus 3 comes out. X and x cancels out. X cancels with x. X cancels with x. So you have only dx. Okay? Plus 3 comes out. 3 is outside. So you are having dx by x. So this is the expression which we are getting now. Please have a look at the expression we are getting now. Okay? Now what do? We directly apply the power formula and see what happens. 4 comes out, x to the power 4 dx. X to the power 4 dx means x to the power 4, here n is 4, so the formula is x to the power n plus 1 divided by n plus 1, so I can write x to the power 5 by 5. Minus 3 dx, integration of dx is only x, plus 3 into dx by x, we know this is equal to log x to the base e plus the constant c. So we have got the answer 4 by 5 x to the power 5 minus 3x plus 3 into log x to the base e plus c. So dear students, let us see this once again. 4x5 minus 4x to the power 5 minus 3x plus 3 by x. We divided that into, we split it, we broke it down into 3 parts. So first 4x to the power 5 by x minus 3x by x plus 3 by x dx. By solving it directly, we have got 4 into x to the power 5 by 5 minus 3x plus 3 into log x plus c. By using the fundamental formula we have learned so far. Okay. Now we take another important formula. Not a problem, but a formula first, and then we shall see problems. Okay. So the formula, kindly note, is ax plus b to the power n dx. Okay. So you have ax plus b. Here a is a constant, b is a constant, and definitely n is not equal to minus 1. Right? And a is a constant, b is a constant. So the solution to this one will be, please note, it will remain ax plus b to the power n plus 1, but in the denominator we will have this a will come. So a into n plus 1. Of course, we have to add the constant of integration, so plus c. So ax plus b to the power n dx gives us ax plus b to the power n plus 1 divided by a into n plus 1 plus c. Okay, so these are all the fundamental and the standard formula which are also given in the study material, and every year in every exam questions keep coming on all these applications. Okay. With this, we move on to the next part of the syllabus in integration, and that is the method of substitution. The method of substitution. Please move on to 8.b.3. So we have completed 8.b.2 and now we proceed to 8.b.3. 8.b.3. Okay. Now here we shall be learning about the method of substitution. Okay. So I'll keep a note of the formula. Ax plus b we have done. So ax plus b to the power n we have done. Now we move on to the method of substitution. Okay. So we are going to substitute. Substitution. Now let us take the example which is given in the study material. Okay, we follow the same example as given in the study material, right? I hope you're all connected and practicing the problems with me. And now we have just started the method of substitution, and the integration we have to do is this one, integration of 2x plus 3 to the power 7 dx. Okay. So what will be the solution to this? Please note the last one which I took up, the last example which I took up was ax plus b to the power n dx. Now do you see any similarity between these two terms? Ax plus b to the power n and 2x plus 3 to the power 7. Do you see any similarity, any type of comparison? Can you compare them? Yes or no? I think yes, because here a is 2, ax, it is 2x, so a is 2 first. Second, b is equal to 3, here b is 3 and n is 7. Now in this case, ax plus b to the power n, if you see the formula, what was the solution? The solution is ax plus b to the power n plus 1 divided by n plus 1, and a will be multiplied. Okay, this is the solution to this particular integration. Okay, ax plus b to the power n dx gives us ax plus b to the power n plus 1 divided by a into n plus 1. Okay, that is the formula for ax plus b to the power n. Now in this case, we have 2x plus 3 to the power 7. Now how do we substitute? Now let's take, say for example, let's take 2x plus 3 is equal to t. So let 2x plus 3 equal to t. Okay. So then it becomes, if you differentiate both the sides, 2x plus 3 equal to t, if you differentiate, it becomes 2 into dx is equal to dt, because 2x into 2x, the coefficient will be 2. So you have 2 dx, 3 differential coefficient is 0. So this will be 2 dx equal to dt, or I can write dx is equal to dt by 2. So now the given expression which you see here, the expression is 2x plus 3 to the power 7. 2x plus 3 to the power 7 dx. So this becomes, we have taken 2x plus 3 equal to t. So the given expression now becomes t to the power 7 dt by 2. So this becomes t to the power 7 dt by 2, because this dx is now dt by 2. Okay? So I hope you are following. So the given expression is, now we are using substitution, and we have taken t equal to 2x plus 3. So this becomes t to the power 7 dt by 2. And when you find this out, when you break it up, you have this dt by 2 means what? Dt by 2 means half, 1 by 2. So 1 by 2 is a constant. So 1 by 2 comes out. So you have 1 by 2 d to t7 dt, t to the power 7 dt. Now t to the power 7 dt is of the form x to the power n, and the formula is x to the power n plus 1 divided by n plus 1. So I can write this half will remain as it is. T to the power 7 will become t to the power 8 by 8 plus constant c. That means it becomes t to the power 8 by 16 plus c. But t to the power 8, fine, t to the power 8 by 16 plus c, great. Fine. But t is equal to what? T is equal to 2x plus 3. T is equal to 2x plus 3. Therefore, the solution becomes, instead of t, we again substitute 2x plus 3. So the answer is 2x plus 3 to the power 8 by 16 plus constant c. So the answer is 2x plus 3 by 6 to the power 8 by 16 plus c. Friends, this method is known as the method of substitution, and it is covered if you look at the portion 8.b.3 of the study material. Now we are taking up some more examples on the method of substitution. So we have done the substitution method also. Substitution. Okay, fine. So we proceed to have some problems on substitution. This is an example which is done in the study material, and I explained it once more, and I'm sure you are now clear with how we are substituting and ax plus b to the power n. How this is coming to ax plus b n plus 1 by a into n plus 1. If you apply the formula, if you don't follow the substitution, if you just apply the formula, in this case, the same result will come. Ax plus b, that is 2x plus 3 into n plus 1. So it will become 2x plus 3 into 7 plus 1. In the denominator you have a is 2. So I write 2 here. Into n plus 1 into 8, that is 16. So the answer, if you follow this direct formula, you will get the same result, 2x plus 3 to the power 8 by 16. The same result comes, 2x plus 3 to the power 8 by 16 plus c. Fine. So now we are moving to the next example, and we will solve it. This is based on substitution. The rule of substitution. It's an important rule in integral calculus, and very frequently in the exam, questions keep coming from substitution also. In the exercises 8b, you will find number of problems which are based on the rule of substitution. I am taking up a very easy example first, and this is x plus 4 cube dx. So x plus 4 cube dx, right? So here I use the simple formula. If let x plus 4 equal to p. Okay, so I am using the method of substitution. Okay, let x plus 4 equal to p. Then I can write dx is equal to dp. Okay, I am differentiating the left hand side. ddx of x plus 4 is dx because 4 will become 0, and right side is dp. So here I will now substitute, and I will write that this becomes x plus 4 is p. So it becomes p cube dp. P cube dp. P to the power 3 dp. Okay. So students, I hope you are following and you are understanding the step-by-step process of solving these type of problems. P cube dp, this means P cube dp is of the form x to the power n. So the solution will be p to the power 3 plus 1 by 3 plus 1 plus c. That means p to the power 4 by 4. But here p is x plus 4. So the solution is x plus 4 to the power 4 by, we are having 4. Okay, so we have taken x plus 4 cube. So it becomes x plus 4 to the power 4 by 4 plus constant c. Please have a look at the solution. This is the pure application of the method of substitution, because I have substituted x plus 4 by p. Okay, now we see another example. So this was x plus 4 to the power 3. I hope you are clear with this. X plus 4 I have taken as p. So differentiating both the sides, if you find out the derivative of both the sides, I am getting dx is equal to dp. I am putting this value here. It becomes p cube dp, which means p to the power 3 plus 1 by 3 plus 1 plus the constant. That means getting the values of p back, I am getting x plus 4 to the power 4 by 4 plus c. Okay. Now I proceed to the next example, and I would request you to note it down and please practice along with me. And the example is 4x plus 4 whole square dx. 4x plus 4 whole square dx. 4x plus 4 whole square dx. If you break it up using the same principles, so I will take 4x plus 4, I will take it as say anything, say s. I'll take it up as s. So let 4x plus 4 equal to s. So 4 dx will become ds. Okay, that is dx is equal to ds by 4. Dx is equal to ds by 4. That means in the given equation, what do I get? I am getting 4x plus 4 is s. 4x plus 4 is s. So I have substituted that. So this becomes s square. S square. But ds by 4. Dx has become ds by 4. So instead of dx, I write ds by 4. So ds by 4. This means 4 means 1/4 of course. 4 is in the denominator. So 1/4 comes out, it becomes s square ds. This means 1 by 4 into s cube by 3 plus c. I am using the direct formula now. You have understood that x to the power n, this is of the form x to the power n. So I directly write s cube by 3 plus c, which means the formula s was nothing but 4x plus 4. So putting back, we get 4 and 3 becomes 12. So 1 by 12 into 4x plus 4 cube plus the constant c. So we are able to solve this problem as well. Right. Now we move on to some more standard formula, and then we will take up the differentiation, integration by parts. Okay. So let us take up the last few formula. These are the standard results. So method of substitution we have done. Now we are going into the standard results, and one more formula, two more formula in fact initially we write. So what happens, you are given dx by ax plus b. Okay. So dx divided by ax plus b, I will write the formula here. Dx by ax plus b we have done. This will be equal to dx by x is log x. So dx by ax plus b will be log ax plus b to the base e. But since there is a here, this will come as a denominator. So please note the rule, dx by ax plus b. Dx by ax plus b integration will give us 1 by a into log ax plus b to the base e. This is a standard formula, and you can use this formula to solve exam questions. It's a standard formula. The next standard formula which we need to note is dx divided by x square minus a square. Dx divided by x square minus a square. So please note that this will be equal to 1 by 2a. 1 by 2a log x minus a divided by x plus a plus constant c plus constant c. So x minus a divided by x plus a plus c. Please note this is a standard result included in our syllabus and very important formula for solving numericals. Dx by x square minus a square. Integration of dx by x square minus a square. The standard formula is 1 by 2a log x minus a by x plus a plus c. So dear students, you can see number of formula in case of integral calculus. It is, I think, more complicated than differential calculus. So I would request you to put in more effort to cover these chapters and to do as many numericals as possible, because this is a critical and crucial chapter. So many formula, so much to remember, and of course it is a new concept. For many of you who are having non-mathematics background, it is definitely a challenging chapter, but then challenging but not impossible. So put in your efforts. When we started with mathematics, you had almost no idea of what is matrix, what is quadratic equation, right? What is indices, what is logarithms. But now, after 1 month, almost 1 month is going to be over. Thanks to the virtual class of the Institute, I'm sure you have better idea. So be positive. I know the chapter is not easy, but I'm sure that you are also putting in your effort. You can see we are doing example after example to make the idea clear to you. Little bit of practice, little bit of patience and time management. I'm sure you will be having better idea as we solve more and more examples, right? But my request to you is please put in special effort for differential calculus chapter, integral calculus and for sets, functions and relations. These 3 chapters are little bit critical and new concepts as well as new formula you need to remember. Okay, so let's see this formula. It's not very easy to remember, but the more practical solutions you do, definitely the formula will stay. You'll be able to retain the formula in your mind. 1 by 2a log x minus a by x plus a plus c. So this is a standard formula, right? Now let me take up an example. Of course, 2 more formula there. Let me write the formula. Okay. After this, the other one is what happens when we have dx square root of x square plus a square. This was dx by x square minus a square. So the formula was 1 by 2a log x minus a by x plus a plus c. Now when you have this type of expression dx divided by square root of x square plus a square, the integration will be, the answer will be dx by x square plus a square. It will be log to the base e, of course, x plus x square plus a square plus c. And if you have minus sign instead of plus sign, if you have negative sign, that means if you have x square minus a square, so I'm writing minus x square minus a square, then it will be the same formula, the same result, the same solution, log x, but here we have plus, now this will become minus. So it will become x minus x square plus a square, square root plus c. Please note, this is also a standard formula given in the study material based on which questions keep on coming. So we are having dx by x square minus a square, okay? So we have done dx by x square minus a square. We have also done dx by square root of x square plus minus a square. Of course, you have other formula like you have dx by x square plus a square, but it will give 1 by a tan inverse x by a, that is outside the syllabus. So I'm not going into the other combinations of this formula because they are trigonometric in nature. They have trigonometric result, sine inverse, cos inverse, tan inverse, which is not included in the exam. So we are focusing on this one and this one, x square minus a square, okay, and we are taking up x square, square root of x square plus minus a square, okay, and the result is in front of you, log x plus minus x square plus a square square root. Fine. Now we are taking up 2 further standard formula. Please note I am referring now to page 8.28 where you are getting all the standard formula. Page number 8.28 of the study material where all the important standard formula are documented for you for your ready reference, and we are covering those formula. Okay. Now we have, I am rubbing these 2 standard formula and we will note 2 other standard formula. Okay. So in integration you have number of formula to remember. Okay. Now if you have a situation like this where you have integration of fx dx, but in the numerator you have f dot x. Please see the situation. The denominator is fx and the numerator is f dot x. F dot x means what? F dot x, you remember I have discussed this in detail in the last class. F dot x means the derivative of fx. That means the differential coefficient of fx. So I can write f dot x is equal to d of fx by dx. In this type of expression, if you get any such question in the exam, very likely to come in the exam. If you get such a question in the exam, the direct answer will be, in this type of expression, the direct answer is log fx to the base e plus c. So please note, this is also a standard formula and we are keeping a note of it. We have done this, f dot x by fx. This is a standard formula. If you have the expression fx in the denominator and differential coefficient of fx in the numerator, then automatically it becomes log fx to the base e. Let me give a small example, you will understand. Say you have got this. Say for example, please see carefully. Please see the example very carefully. Okay, you have 8x dx divided by 4x square plus 5. Please see carefully. Do you see any relation between the numerator and the denominator? The denominator is 4x square plus 5 and the numerator is 8x. I'm sure you are able to see the connect. I'm able to explain this using this formula. So 4x square plus 5, if you differentiate 4x square plus 5, that means if you find out the differential coefficient of 4x square plus 5, what will you get? You will get 8x. Because you know nx to the power n, differential coefficient is what? Sorry, x to the power n, differential coefficient is what? X to the power n minus 1, nx n minus 1. So in this case, you will be getting 4 into 2x to the power 1, that is 8x. Now 8x you already have here in the numerator. Please see the expression, 8x by 4x square plus 5 dx. Now this expression and this expression, okay, if you carry out the differential coefficient of 4x square plus 5, you will get 8x. So this is of the form f dot x by fx. So the direct answer to this will be, the answer is log 4x square plus 5. 4x square plus 5 to the base e plus c. Okay? But of course there will be adjustments because we are having 4 here. There will be further adjustments. But the answer is this. So fx and f dot x, if you have, directly we can take this. Okay. Now we will go into the integration by parts. Just wanted to explain this. Of course, a simple formula is, I think let's do it. And that is regarding Ex. It is a standard formula. If you get a problem like this, where you have to integrate Ex, e to the power x, and the relation is like this, fx plus f dot x dx. If you get any integration of the form e to the power x, fx plus f dot x dx, then the direct answer to this is e to the power x fx plus c. So this is also a standard formula, you can remember this. So e to the power x fx plus f dot x. This is also a standard formula, right? And questions keep coming from here. Now we go to integration by parts, and this is 8b4. So we have completed 8b3. We are proceeding now to 8b4, and this is integration by parts. Okay. Integration by parts means what happens when we have two functions like a product. Product integration by parts actually means product rule. Okay. So we have done addition rule, we have done the subtraction rule, we have completed substitution. we have done dx by ax plus b. We have also completed dx by x square minus a square, standard formula and the standard results. Now it's time for the difference integration by parts. Now in this case, let us have two, of course it's a product of two functions. So I'll be taking two functions and I will call it u and v. Okay, so u is a function of x, let it be fx, and v is a function of x, let it be gx. Okay, now we have to calculate u into v dx. This is a bit complicated. I request your undivided attention. Keep aside your pen and paper. Please understand this first and then you note. Okay, this is the critical part of integration. U into v dx. Okay, once again I request you to understand that today being the last day of mathematics section, you can understand that we are dealing with the toughest chapter because the toughest chapter is usually kept at the last. So please have patience, have the belief in yourself, definitely will understand. It may take a little bit of time, but please concentrate. I am sure things will become clearer to you. U into v dx. Let us see the rule. U is a function fx and v is another function gx. Two functions. How to integrate? This is called integration by parts. So part by part we will integrate. So the rule is, in this case, first keep u outside and first integrate v dx. Then minus. Now a big integration sign because first in this you have to now differentiate u. So you have to carry out du by dx. And this will be multiplied by v dx. And the whole will be integrated. Okay. This is a very, very tough one. I can understand. But please try to understand and step by step analysis I am doing so that it becomes little bit easier and you will be able to apply this formula. Please note, number of problems in the exam comes on this formula, integration by parts. So what we are doing is, first u I am bringing out. Okay, and u I also differentiate. I carry out the differential coefficient. So du by dx. I take up v dx first. V dx first. And then du by dx I multiply again by v dx and the whole, that is du by dx into v dx, the product is again integrated. Okay, this is a critical one and we will take examples to understand this. Very important portion of our syllabus. So you have to know and you have to understand it for the sake of exams, for the sake of your marks, and this is how we do it. We bring the first function out, integrating the second function. Second function is v dx minus subtracting du by dx multiplied by v dx and the whole and the product v dx integration into du dx is then integrated. Okay. Let me take the shortest example, smallest example. Okay. I'll take log x. We'll integrate log x. Okay. I'll keep the formula here. It is integration by parts. So we have done by parts. Let us take the example log x. Okay. We are trying to integrate the expression log x. Integration of log x dx. Okay. So what we do is, log x can be written as integration of log x into 1 dx. Log x into 1. Now, I apply integration by parts and I have two functions. One is u and the other is v. Okay? U and v. I take log x as u. So I write let u equal to log x and let v equal to 1. So v will become 1. So now I apply integration by parts, right? What we learned, and here log x becomes the first function. So I bring out u is the first function. First function I bring out. So I write log x outside and I take up 1. 1 means it will be only dx. Fine? Minus. This minus sign comes here. Now I do the differentiation of log x. Log x is u and you have to carry out du by dx. So d dx of log x multiplied by dx and the whole will be integrated. Please see the step once again. So we have taken log x dx, we want to integrate that. We are applying integration by parts. So we have taken first function as log x and the second function as 1. Now we are multiplying log x into 1, dx gives me log x. I am taking log x as the first function. So log x is outside integration. Dx minus ddx of log x, because log x is the first function. As per integration by parts, here you have to differentiate the first function. That means you have to find out the derivative of the first function, multiply it with dx, and the whole is integrated. So now it becomes log x. If you integrate only dx, the answer is x. So you have log x into x minus ddx of log x. I open the integration sign. ddx of log x is 1 by x into dx is x. And we take dx again. This dx comes here. So this becomes x cancels out. So what I am getting is log x into x means x log x minus this becomes dx only, so that means it is x plus c. So the answer of log x dx using integration by parts, the solution is x log x minus x plus c, where c is the constant of integration. X log x minus x plus c. Let's see the entire formula once again. Integration by parts. 8b4. Section 8b4 of our study material. So what we have done is we have taken u as the first function, b as the second function. In our example, log x is the first function and 1 is the second function. So u is log x, b is 1. Accordingly, I have kept log x outside and I have differentiated 1. 1 means only dx. Minus sign, this minus sign comes down. ddx of log x, because here we have to do du by dx. U is the first function. So here log x is the first function. So ddx of log x. Multiply that by integration of v. V is 1. So only dx. And the entire part is again integrated. So double differentiation, double integration basically. You again integrate. So first part is dx. If you integrate, you get x. So x log x we have got. Minus log x differential coefficient is 1 by x. This x, 1 by x, cancels with x because dx is x. X and x cancels out. This dx comes here. This dx comes here. So if you see here, x cancels out. So you get only dx. Integration of dx. Only integration of dx if you do. Integration of dx, that is x. So we have got x. So the answer is x log x minus x plus c. This is what we call integration by parts. Okay. Please remember the formula, otherwise without the aid of the formula, you will not be able to carry out these type of questions. Right. Now let me take up one more example. Okay. So I'm rubbing this. This is the toughest formula, integration by parts. You have to take two functions and make sure that you have the right functions. I mean, you must take the right function, the correct function as the first function, and always take that function as the first function where you can find out the derivative easily. Because please remember the first function, u and v. U is the first function. With regard to the first function, u, you have to find out the derivative also, especially when you are applying the formula of integration by parts in this particular formula. So, remember to take the first function as the function which is easier for differentiating. That is, the function which is easier so far as finding out the derivative is concerned. Okay. Now let me take one more example, and this is, let me take this one. 5x square into x cube minus 4 to the power 4 dx. So we are taking gradually more difficult examples. So let us take this 5x square into x cube minus 4 to the power 4. So let u equal to x cube minus 4. X cube minus 4. Okay? Then we can write du, differentiating both the sides. We can get du is equal to 3x square dx. Okay? U equal to x cube minus 4. That means by applying differential coefficient formula, du is equal to 3x square dx. Because minus 4 differential coefficient will be 0. Okay? So this is what we get. Now in the given example, we are having, please see, we are having 5x square divided by x cube minus 4 to the power 4 dx. Now I can write this as, carefully please see, 3x square by x cube minus 4 to the power 4 dx into 5 by 3. Please see this step, very important step. I have got 5x square, but I need to get 3x square dx. Only then I can apply the formula. So I have 5x square. I need to get 3x square. So what I am doing, I am writing 3x square, but I am multiplying it by 5 by 3. So that 3 cancels and I shall get 5x square. So I am splitting it and writing in different form. This once I achieve, this becomes easy now, because now x cube minus 4 is u. So 3x square dx is du. So the entire expression becomes 3x square dx is du, and in the denominator we have x cube minus 4. This is equal to u to the power 4, and outside we have 5 by 3. So the formula is, what do we get here? Sorry, we have, this is multiplying, sorry. So u4 will be in the numerator, sorry. u4 is here. This is numerator, so I'll just rub this. X cube minus 4 is numerator, right? X cube minus 4 to the power 4 is the numerator, right? So this formula becomes, what are we getting? We are getting 5x square. I have written this as 5 by 3. 3x square into x cube minus 4 to the power 4 dx. Now 3x square dx is du. So I can write, and x cube minus 4 to the power 4 is u to the power 4. So I can write this as u to the power 4 du. This is of the form x to the power n. So this becomes u to the power 5 by 5. But outside we have 5 by 3. So into 5 by 3. So 5 and 5 cancels. You are getting u to the power 5 by 3 plus constant c. But u is how much? U is x cube minus 4. So the answer to this will be 1/3 x cube minus 4 to the power 5 plus c. So this is the answer. So here what we have done is x cube minus 4 is, if you take it as u, then 3x square becomes du. So it becomes u to the power 4 du. You break it up into u to the power 5 by 5. And this is an example of substitution, as well as we are using the differential coefficient. So you can see, for solving this type of problems, we also need to have good idea about the concept of differentiation. That is finding the derivative. We now proceed to 8.B.5 to see partial fractions, which is the last part. So 8.B.5, and this is the last portion. So we see partial fractions. Now partial fractions, I will directly go with an example so that it becomes easy for you. Let's take an example like this: 3x plus 11 dx divided by x squared minus x minus 6. Please see the numerical. Integration of 3x plus 11 divided by x squared minus x minus 6. We are now using partial fractions. It is called partial fraction method. Okay. So I am writing here partial fraction is done. Okay. Let us take this. How to do this? First of all, please see the denominator. X squared minus x minus 6. Once again, I am saying that this chapter being the last chapter, it is assumed that by now you have got a sound knowledge of equations, right? And of course other chapters. Now why I am saying equations, especially quadratic equation, because what you see here is a quadratic equation. Now if I break this up, what do I get? I am getting x squared, let me work it out here, x squared minus x minus 6. If I split up, what do I get? Using quadratic equation, I can write like this: x squared minus 3x plus 2x minus 6. So this gives me x, taking x common, x minus 3 plus 2 into x minus 3. So this gives me x minus 3 into x plus 2. So I get x minus 3 into x plus 2. So this expression, what you see here, can be broken down into, I can write it as a by x minus 3 plus b by x minus 2. Okay? If you add them up together, then the LCM of x minus 3 and x minus 2, the lowest common multiple LCM will become x squared minus x minus 6. And accordingly you will get 3x plus 11. Now if you combine this, what do you get? Let's see carefully. So I can write, if you multiply them, I can write that this is equal to a into x minus 2. A into x minus 2 plus b into x minus 3. B into x minus 3. This should give you 3x plus 11. Please see this. Okay? We are adding the coefficient here a into x minus 2, the constant here, plus b, the constant here, into x minus 3. This should give you 3x plus 11. In other words, what I get is, this when you break it down, you are getting ax minus 2a plus bx minus 3b. This should be equal to 3x plus 11. Ax plus bx, I can write this as a plus b into x minus, I am having 2a ax minus 2a minus 3b. So I am getting minus 2a plus 3b. So I can write this as 3x plus 11. So from here I am getting, you can easily understand that a plus b, what you see here, a plus b equal to 3. So I can write, because the coefficient a plus b, here we have 3, a plus b x minus 2a plus 3b is plus 11. Okay? So I can write, once again if you break it up, what am I getting? Just let me see whether we have done it correctly. X minus, no, we have x plus 2, today x plus 2, sorry, x plus 2 here. Okay, so this will be ax, just check, x minus 3 is done, x plus 2 is done. Okay, so we are getting a into x plus 2 plus b into x minus 3 is 3x plus 11. That means ax plus 2a plus bx minus 3b is 3x plus 11, which means a plus b into x, okay, ax and bx is a plus b into x. This will be plus 2a minus 3b, okay, plus 2a minus 3b, this is equal to 11. Now if you see the coefficient, a plus bx, here we have 3x. That means a plus b has to be equal to 3 and 2a minus 3b has to be equal to 11. 2a minus 3b has to be equal to 11. 2a minus 3b has to be equal to 11. So if you substitute the formulas, if you solve the formulas, we are getting two simple equations. I will try to solve it here. We have a plus b equal to 3. A plus b equal to 3 and we have 2a minus 3b. 2a minus 3b equal to 11. So I will write 2a minus 3b equal to 11. So you can easily solve it by multiplying equation 1 by 2. So you are getting 2a plus 2b equal to 6. So 2a and 2a cancels out. You have 2b and 5b is equal to 5b is equal to 5 minus 5 and b equal to minus 1. So we are getting b equal to minus 1. If you solve for a, you will get a equal to 4. So now all this using partial fraction breaks down and what you get is a very simple expression. After solving this, what you get is a by x minus 3. A is 4. So you are getting this equation is equal to 4 by x minus 3 dx plus b by x plus 2. Now b is minus 1. So you are getting minus 1 dx by x plus 2. This becomes 4 dx by x minus 3. And dx by x minus 3 gives you log x minus 3 to the base e. Plus of minus, so it becomes minus. Dx by x plus 2 becomes log x plus 2 to the base e. So this is the answer. 4 log x minus 3 minus log x plus 2 plus the constant of integration c. This is partial fraction. What we do here is we break the denominator into two factors and then we combine the factors, we adjust the factors in such a way so that we get the numerator. Here also we have done the same thing. We have first factorized x square minus x minus 6, x square minus x minus 6. We have broken it down. We have got x minus 3 into x plus 2. So we have brought x minus 3 here, x plus 2 here, and once you adjust x minus 3 and x plus 2 in this way, what will happen? A into x plus 2 plus b into x minus 3 should give you the numerator. So we have compared them and we have got a plus b equal to 3 and we got 2a minus 3b equal to 11. We solved for the equations and we got b equal to minus 1, a equal to 4. Putting the same in the equation, we were able to solve this equation and we got 4 log x minus 3 minus log x plus 2 plus the constant of integration c. Fine. Now we proceed to have the last part and we will take an example 8.32, page number 8.32. Okay, so we have done partial fraction as well and we have solved the equation. Let's take. So this also you can see is a long chapter and a complicated chapter. We have already completed 2 hours non-stop, 2 to 4, and we have to push further so that we can complete. This being the last class of calculus, we have to complete including the questions from 8B. So we'll push further. Okay. Now 8.32, page number 8.32, and we have to cover each and every concept because if I cut short on the time and if I want to jump to another section without first completing the earlier part, then you will not understand. So step by step, that means time. Time is the main constraint, right? So we have to push further today. 8.32 page number. Please see the question. Find the equation of the curve. You have to find the equation of a curve where the slope is given. The slope is 9x and it passes through the origin. It passes through the origin. Origin means 0, 0. So we have to find out the equation of a curve. It is given that the slope has the equation 9x. You may remember last day I was discussing about the slope. Vertical by the horizontal part. Tan theta. Slope. Steep. As the theta angle becomes bigger, the slope becomes more steep. So the slope is nothing but, if this is a curve, the slope is the tangent. This tangent. Okay? So you can see the concept of slope is very important. Now, the slope is 9x. Very good. That means the equation is 9x. Y equal to 9x. Fine. So I have to find out what is the equation of the curve. I know the equation of the tangent, the slope. Okay, tangent. So I have got a linear. Y equal to 9x means linear, straight line equation. So now, in order to find the equation of the curve, what I do, I integrate. So y equal to 9x. So y, if you integrate, you will get 9x dx. So 9 comes out, you have x dx, and this becomes 9 into x square by 2. Plus, of course, the constant. 9x square by 2. Now, the question, please note, is that now that means the equation is y equal to 9x square by 2 plus c. Please note the equation. Y equal to 9x square by 2 plus c. This gives the equation of the curve. But, please see the question. It passes through the origin. The curve passes through the origin. That means, if this is 0, 0, the curve passes through 0, 0. 0, 0. X-axis, Y-axis. It intersects at 0, 0. X 0, Y 0. So the curve is passing through 0, 0. It means what? It means when Y is equal to 0, when X is equal to 0, Y is also equal to 0. So if you put X equal to 0, what you are getting is, right hand side becomes 0 by 2 plus C. Left hand side is 0 because 0, 0. It passes through the origin. Origin means 0, 0. X 0, Y 0. So that means here the constant is equal to 0. So the equation of this curve becomes y, I write it here, it becomes y equal to 9x square by 2. That means 9x square equal to 2y. This is the equation of the curve. Okay? So it's a very important question given in the study material, and that is how we get it. So once again you see 9x gives you the equation of the tangent. If you integrate the tangent, you get the equation of the curve. We have done it. So 9x dx we have integrated. We have got 9x square by 2 plus c. Now since the curve passes through 0, 0, the origin is 0, 0, x is 0, y is 0. So since passes through the origin, so I can equate this. X is 0, y is 0. So we get 0 plus c equal to 0, which means the constant c is also equal to 0. This gives us the equation of the curve is 9x square equal to 2y. Okay. Now we come to the last part, and that is definite integrals, 8.B.6. Okay. The last part of our syllabus, definite integrals, and then we will quickly go into the questions. Okay. 8.B.6. 8.B.6 definite integral. I have already explained about it in the beginning. So partial fraction is done, and definite integral we are now doing. Definite integration. So definite integration, dear students, is very simple. If you have a function fx dx and a limit is given to you, upper limit and lower limit. So lower limit is A, upper limit is B. That means what you need to do is, once you solve it, fx ds, once you solve it, say it becomes f, capital Fx. So now you have to find out the value of capital Fx for A and B. Two values, which means the answer will be FB minus FA. Okay, this will give you the quantum of definite integral. So here B is known as the upper limit, A is the lower limit, and you have to find out FB minus FA. This is the concept of definite integral. So this is what we call definite integral, because you are definite. Why you are definite? Because you have two limits, you have B and A. So you know that this is a function, I know the limit, lower limit, upper limit, A and B. A is the lower limit, B is the upper limit. So I can find out the area in between, right? Once again, we saw the graph, we just did the equation of a curve, and you saw that the curve was passing through the origin, 0, 0. This is y-axis, this is x-axis. So the curve was like this. Now, if you are told that can you find out the area of the curve, this and this, say x is 5 and x is 10. So the area of the curve which is there between x equal to 5, y0 and x equal to 10, y0. So this will be the area of the curve. I have shaded it. Okay, I have put some shade. Okay, this is the area. So that means here 5 is the lower limit and 10 is the upper limit. 5 is the lower limit, 10 is the upper limit. What we are doing, say the equation of the curve is, I am just writing the equation, say let it be y equal to 4x square plus 5. That means what we are doing is, in this case, lower limit is 5, upper limit is 10. Okay, this is called definite integral. What we are actually doing is, we are integrating 4x square plus 5 dx, but the limit, please note the limit, the lower limit is 5 and the upper limit is 10. Because we are given these two limits in this case. This is how definite integral is used to find out the area of a shade of a particular shaded region, in this case the area of a curve, and the area between the curve and the x-axis. Okay, so this is what is called definite integral, and now we will take an example to clarify. Okay, let me take a very small example, you will understand. So I am rubbing this part and I am taking a very small example of definite integral, and then we will go into the question answers. Okay, say we have this integral x cube dx. X cube dx between the limit minus 2 and plus 2. So the lower limit is minus 2 and the upper limit is plus 2, and the expression is x cube dx. So what do we do? This is what type of integral? It is a definite integral, because you are given lower limit and upper limit. Okay, so what we do, let us first solve this. So x cube dx we know is of the form x to the power n. So it becomes x to the power 3 plus 1 by 3 plus 1 plus constant. But since it is a case of definite integral, okay, so we know the exact area. So we have the limits minus 2 and plus 2. So what we do is, this becomes x to the power 4 by 4. So now we calculate x to the power 4 by 4 within the limit minus 2 and plus 2. Very simple. What do we do is, we put x equal to plus 2 first. So we get 2 to the power 4 by 4. Okay, so 2 in place of x, 2 to the power 4 by 4 minus, we take minus 2. Okay, minus 2. In fact, what you can do is you can bring out 1 by 4 from here, and let's calculate like this. So 2 to the power 4 minus 2 to the power 4. So in this case, we are getting 2 to the power 4 minus 2 to the power 4. In fact, it gives you 0. So the answer is 1 by 4 into 0, that is 0. So we first find out the solution to the integration, and then we put the value of the lower limit and the upper limit, and what we get is f of 2 minus f of minus 2. That means the function keeping upper limit minus the function keeping the lower limit. The difference gives you the quantum of the definite integral. Now the last is the properties of definite integral, and we will take few properties with which we will complete, because this is the last part of our chapter on integration. In case of definite integral also, all the rules are same. That means if you take the sum and the difference rule, fx plus gx, okay, plus minus I am taking, and if there is an integration between a and b, okay, so fx plus minus gx dx, and the limit is a and b. Two limits are given, a and b. What will be the answer? Here also what we will do is, we will first take fx dx between the limits a and b, plus we will take again gx dx between the limits a and b. The same rule will be applicable for minus sign also. So the sum and difference rule is this. Okay? Fine. Now the second rule is, we have zero length interval rule, which says, what is the zero length interval rule? It says that if you have a integral like this, fx dx, and the region is from a to a, this will obviously be 0, because a to a, okay, lower limit is a, upper limit is a, both are same, so it will give you 0. Plus we have a constant multiplier rule, which you know already. So if you have k into fx dx within the range a to b, the answer will be, k will come outside, k into fx dx within the range a to b. So this is the constant multiplier rule. And the last rule is interval rule, which says that if you have a particular expression like this, fx dx a to b plus fx dx b to c, so you have a to b and b to c, then the answer will be fx dx a to c. So you may remember in the functions chapter we did reflexive function, symmetric function and transitive function. 1, 1, 2, 2, 3, 3 is reflexive. 1, 2, 2, 1, 1, 3, 3, 1 is symmetric. And 1, 2, 2, 3, 1, 3 is transitive. So this is a case of transitive. AB, BC, and therefore AC is transitive. So fx dx a to b plus fx dx integration b to c will give you complete area a to c, transitive nature. So this is what we have so far as the properties of definite integrals are concerned. And now we proceed to the exercises to solve questions. It's around 4:25. We'll just proceed with the question 8b. Okay. We'll first go to exercise 8b. We have completed the curriculum. Once again, before I proceed to the questions, we started with the concept of integral. It is the opposite of differential. It is also called antiderivative. Then I explained to you the basic formula x to the uses of integrals we have done, the applications of integral calculus, right? Then we proceeded to know the power rule, x to the power n. Then we went into the constant multiplier rule. I demonstrated it. Then we discussed about the addition rule of integration, the subtraction rule of integration. Then we did the integration of dx by x, which gives you log x. I also explained why you have the constant of integration. and I was repeatedly requesting you to note that please don't forget to write the constant of integration C or K. I explained why we need the constant of integration. Then we did kx to the power n dx. After that we took up e to the power x dx, the formula. Thereafter we took e to the power kx dx, and we also took a to the power x dx. After that we took a to the power kx dx. Then we completed the discussion on the equation, on the expression ax plus b to the power n dx. Thereafter we moved and discussed about the rule of substitution, which you must have noted. I did some examples. Thereafter we went into the standard formula and we discussed about dx by x square minus a square, plus we did dx by square root of x square plus minus x square plus minus a square. Thereafter we moved on to the other rule, which was, you can remember, f dot x by fx dx. Okay, and this becomes basically log fx plus c. Then we did the integration by parts, which is a complex part with complex expression. We solved it u v dx. So we took u outside, then v dx minus du by dx into v dx. Full will be integrated. Then we took up partial fractions, and I showed you how the numerator can be expressed in terms of the denominator, and we took an example to show what will be the value of a and b, by which we can break down the given expression into two factors, a by something, b by something, and it will straight away lead to the solution. After we completed partial fractions, we went into definite integral. I also explained how through definite integral we can find out the area within a curve, right? And now we are taking up, since we have completed the rules of definite integral, the entire syllabus for integral calculus is over, and now we focus on 8b. Exercise 8b, I am taking up the first question, which is integration of 5x square. We'll spend around 15-20 minutes, and I hope to complete by 4:45 to 4:50. That is the expected time of completion, so that I'll be taking around 15 questions from this exercise. Okay, so I rub out these already. All the questions, all these formula has been discussed, and I have kept a note of whatever we have completed today. So first one is integration of 5x square dx. Question number 1, integration of 5x square dx. Simple. Bring 5 outside. 5 comes out. You have x square dx. This is of the form x to the power n. So we know the formula is x to the power n plus 1 by n plus 1. So this will become 5 into x to the power 3 by 3 plus c. So the answer is 5 by 3 x cube plus c. I move on to number 4. Question number 4 of exercise 8b. Okay. We have to find out this integration x square minus 1 dx. X square minus 1 dx. Using the fundamental rule of addition and subtraction, we break it into this x square dx minus dx. Minus 1 means only dx. So this becomes x square dx is of the form x to the power n. So it breaks into x to the power n plus 1 by n plus 1. So it becomes x to the power 3 by 3 minus integration of dx, only dx, we know the answer is x. Okay. So this is x cubed by 3 minus x plus the constant of integration. I take up question number 9 now. We have to integrate x into x square plus 4 to the power 5 dx. Okay, x into x square plus 4 to the power 5 dx. Please note the form of this question. Now, this is substitution. So what I do here is, please see the question. What I do here, let me try to solve it. Let's see if I can solve it or not using the rule of substitution. So here, let x square plus 4 equal to, say I take p. Fine. So I can write, taking the differential coefficient of both the sides, I can write 2x dx equal to dp, because differential coefficient of 4 is 0. So 2x dx equal to dp. Okay. In other words, I can write x dx equal to dp by 2. X dx is dp by 2. Now I put this value back into the equation. So I am getting here x square plus 4 to the power 5. X square plus 4 is p. So I can write p to the power 5. I am getting x dx. X dx is dp by 2. So I write p to the power 5 dp by 2. Now by 2 means it is half. So I bring out half here. Okay. So x square plus 4 I have taken as p. It becomes p to the power 5 dp. P to the power 5 dp. Half comes out. This is equal to half into p to the power 5 dp is of the form x to the power n. So once you integrate, it will become p to the power 6 by 6. So the answer is 1 by 12 p to the power 6 plus the constant c. But p here stands for x square plus 4. So the answer is 1 by 12 x square plus 4 to the power 6 plus c. Okay, so we have solved this. Please check it with the answers. I am just solving the problems, right? You will have to see whether the correct answer. Please check it with the correct answer, right? So this is how we solve number 9. I am taking up number 10 now. I'll rub this. We have done 1, 4 and 9. Okay, so just keeping a note, exercise 8b. Up till now we have done 1, 4 and 9. Now we are taking up 10. Number 10. Okay, question number 10. Integrate x plus a to the power n. X plus a to the power n dx. Okay. So this will be simple. This is of the form, let x plus a equal to, say, take it as anything, say take it as d, fine, x plus a equal to d. So this is of the form, so dx equal to, let's take this as q. So this dx is equal to dq, okay. Differential of x is equal to dq because differential coefficient of a will be 0. So if you take the derivative of the left hand side, it is dx. Right hand side becomes dq. So I will put, this is substitution method. Number 10 is a substitution method problem. So x plus a, I will take it as q to the power n, and dx I will put dq. So this is q to the power n plus 1 by n plus 1 plus c. But q is x plus a. So this will be x plus a to the power n plus 1 by n plus 1 plus c. Please check the answer. Check it with the answer given in the study material. Right? So this is directly we are solving x plus a to the power n, and it gives us x plus a to the power n plus 1 by n plus 1 plus the constant c. I now take up number 11. So 10 is done. We now take up number 11. Question number 11, one by one we are solving and going ahead. 11. 11 is integrate 8x square by x cube plus 2 whole cube dx. 8x square divided by x cube plus 2 whole cube. Okay, this is the given expression. So what I do is I again substitute and I take let x cube plus 2 equal to, say I take it as p. So I can write taking derivative of both the sides. Okay, taking derivative or differentiating both the sides, what I get is 3x square dx equal to dp. Okay, right? Or I can write x square dx is equal to dp by 3. Fine. I take this and put it here. So the given expression now becomes, I can keep 8 outside. You have x square dx. X square dx is dp by 3. So I write dp by 3. And here in the denominator I have x cube plus 2. That is p cube. So it is 3p cube. The expression reduces to dp by 3p cube. If I break it up, it becomes 8 by 3 dp by p cube. This is equal to 8 by 3 integration of p to the power minus 3 dp, because dp by p cube is equal to p to the power minus 3. The index number reverses indices. So this is equal to 8 by 3 p to the power minus 3 plus 1 by p minus 3 plus 1 plus constant x to the power n plus 1 by n plus 1. Okay, so this reduces to 8 by 3. In the denominator you have minus 2, so into minus 2. In the numerator you have p to the power minus 2 plus c, but p is x cube plus 2. So the answer is, this cancels, so it becomes minus 4 by 3 p to the power minus 2, that is x cube plus 2 to the power minus 2 plus c. The answer is minus 4 by 3 x cube plus 2 to the power minus 2 plus c. Please note the way in which I am solving each of the problems and just check it. I am doing fast, may commit some mistakes, but just check it later on. Right, I am trying to make it as accurate as possible, but so many problems one after the other, right? So back to back, so maybe I may commit some mistakes, but I am just trying to check. Okay? Minus 4 by 3 x cube plus 2 to the power minus 2 plus c. Fine. Now we proceed to number 12. This is 11 is done. I am taking number 12 now. Okay. I am taking question number 12. Number 12 here. So question is integrate 1 by dx by x square minus a square. X square minus a square. Of course, there is a direct formula for this, but the question is you have to use partial fraction. There is a direct formula, but let us do it through partial fraction. It is very simple if you break it up. Now x square minus a square, if you break up, it is x plus a into x minus a. So I can write it in this way. This is equal to, I can write as a by x plus a. Okay. I can write it as plus b by x minus a dx. Okay. X plus a and x minus a. Now if you see, what happens is, if you put it in this way, x plus a, if I do it in this way, minus, if I do minus, then what I get is, if the LCM is x square minus a square, then I get here x plus a, if I write, then I get x minus a here, minus x plus a. So you are getting x minus a minus x minus a. X minus x cancels out, you get minus 2a. Okay. But if I take plus, then what do you get? If I take plus, then it will not come. Okay. So, I will do what? I will reverse it. Okay. We are using all possible methods. So, I will reverse it and I write like this. A by x minus a minus b by x plus a. Let us see whether it comes now. So, here it will be x square minus a square is the LCM. X minus a will go x plus a. So, it will be x plus a minus x minus a. So, now it will give x and x will cancel, a plus a, that is 2a. Fine. So, we have got the answer. What we will do is we split the numerator like this. This will become 1 by x minus a minus 1 by x plus a dx. But we are getting 2a. There is no 2a here. Okay. So what we do? We bring out 2a in the denominator. So that this 2a and the 2a in the numerator, this a and a becomes 2a in the numerator. The 2a in the numerator and the 2a in the denominator will cancel out. Okay. So what we get is 1 by 2a dx by x minus a minus dx by x plus a. Now dx minus x minus dx by x minus a, straight away we can write log x minus a, because the integration we have done. Dx by x is log x. So this becomes 1 by 2a log x minus a minus log x plus a. You know log a minus log b is equal to log a by b. So the given expression becomes 1 by 2a log x minus a by x plus a plus c. Now if you compare this answer with the standard result, you will see that we have achieved the right answer, because the standard result of x square minus a square is the same, 1 by 2a log x minus a by log x plus a, log x minus a by x plus a plus constant. So we have done the 12th one also. I move to the 18th one, 18th question. This is a question on definite integral. Okay. So we are solving number 18 now, and 18, question number 18, 1-8. I'll keep a note of this, 18. Okay. So in question number 18, the idea is you have to integrate. It's a definite integral. Limits are given. Integrate 2x square minus x cube. 2x square minus 8 minus x cube. Sorry, x cube dx. The limits are given between 0 and 1. So it's a question of definite integral, and we have handled and solved similar questions so far. So let me try out and see what happens. So we use the subtraction method. First we do it like this. 2 into x squared dx minus x cube dx. The first step. This boils down to 2 into x cube by 3 minus x4 by 4 plus c. X cube becomes x cube by 3. I am using directly the formula x to the power n. So x to the power n by n plus 1. So x to the power 2 plus 1 by 2 plus 1. Here x to the power 3 plus 1 by 3 plus 1. So this is what we get. So we are getting 2x cube by 3 minus x4 by 4. Now the limit is 0 to 1. So we have to find out the value of this expression. Lower limit is 0, upper limit is 1. Okay. Now if you put x equal to 1, what do you get? In this expression, what do you get? 1 cube is 1. So you get 2 by 3 minus 1 by 4. Minus 1 by 4. Fine. And if you put x equal to 0, the whole thing becomes 0. So minus 0. So the answer is 2 by 3 minus 1 by 4. That is 12 is the LCM. 3 4s are 4 2s are 8. Minus 4 3s are 12. So the answer should be 5 by 12. Please check the answer in the study material. The answer which I am arriving at is 5 by 12. And this is the process. We have first broken it into 2x square and x cube. Two parts. We have solved the integration. Applied the value of 1 and 0. The lower limit is 0. The upper limit is 1. And that is how we achieve the value 5 by 12. Now I am taking up number 27 quickly. Question number 27 from the study material, exercise 8B, number 27. Okay, so we have to 27. We are taking up integration of x to the power 4 plus 3 by x dx. X to the power 4 by 3 by x dx. Direct application. We break it up. X to the power 4 dx plus 3 I bring out. It's a constant I bring out. So you have dx by x. Dx by x. X to the power 4 is of the form x to the power n. So when you bring it out, it becomes x to the power 4 plus 1 by 4 plus 1 plus 3 into dx by x. Integration of dx by x is log x. So we directly write log x to the base e, of course, plus k. And this becomes x to the power 5 by 5 plus 3 log x to the base e plus k. This is the answer which I am arriving at. Please do check it. x to the power 5 by 5 plus 3 log x plus k. This is number 27. Now we take up 28. Okay. Question number 28 of the study material, exercise 8b. 28. The question is integrate 1 minus x cubed by x. So 1 minus x cubed dx by x. Please check it carefully. 1 minus x cubed by x. We expand the numerator straight away. So this is of the form a minus b whole cube. So this will be equal to 1 minus x cubed minus 3a square b. So 3 into 1 into x minus 3x plus 3ab square. So minus 3 plus 3x square by x. So now break it up, split it up. So this becomes 1 by x. So dx by x minus x cubed by x. So minus x cubed by x dx minus 3x plus 3 into x square by x dx. So 1 by x cubed by x, 3x by x, 3x square by x. Now we directly arrive at the result. Dx by x is log x minus x cubed by x. So cancels x square. So this becomes x cubed by 3 minus 3 into x dx by x. X and x cancels out. So this becomes 3x plus 3 into x square by x. So again it cancels out. You have x dx, which means x square by 2 plus constant c. So it reduces to log x minus x cubed by 3 minus 3x plus 3x square by 2 plus c. Okay, this is number 28. Log x minus x cubed by 3 minus 3x plus 3x square by 2 plus constant c. This is the answer I am arriving at. Just check it with the study material as well. Okay, so this is how we break number 28. I proceed now to 29. It's a question of a curve. Number 29. Just push for another 10 minutes and ensure that the entire questions, maximum number of questions, tricky questions also I am taking. Okay, so number 29 now. 28 is done. I am taking 29. 29. Equation of the curve is 2x minus 1. The tangent f dot x. Please see number 29. The equation of the curve is of the form y equal to fx. Very good. And the curve is passing through the point 1, 0. 1 and 0. The curve is passing through the point 1 and 0. And f dot x is 2x minus 1. F dot x is 2x minus 1. That means this f dot x equal to 2x minus 1 is nothing but the equation of the tangent, the slope. So the slope. So therefore, what to do? You have to find out the equation of the curve. Question number 29. So what we do is, we integrate this. So if I integrate, I get 2x minus 1 dx. I want to integrate. This will be 2 into x dx minus only dx. I hope you can follow, dear students, now, right? You have the knowledge of the rules and the basic formula and the standard results. So this becomes 2 into x dx is x square by 2, minus only dx is x, plus the constant c. So 2 and 2 cancel, so you get the equation x square minus x plus c. But the work is not complete. Y is equal to this. The curve is equal to this. We have got the equation of the curve, but there is a constant c. I think it is given in the problem that the curve is passing through 1, 0. That means the curve is passing through the coordinates x equal to 1, y equal to 0. So I will put this here. I will put this relation here. y equal to x square minus x plus c, I will put x equal to 1, y equal to 0, and let us see what happens. I will put x equal to 1 here, so y is 0. So 0 is equal to 1 square minus 1 plus c. That is 1 minus 1 plus c. That means c is equal to 0. So therefore the final equation of the curve is, you can easily understand, the equation will be y is equal to x square minus x, because c is 0, so x square minus x. This is the equation of the curve. Okay, and that is what we have to find out as per question number 29. I now proceed to question number 33, which is also a question on definite integral. Okay, 33. We will take 3 or 4 questions and then we will wind up. So 8b exercise 38b, question number is 33 I am taking. Okay, question number 33. We have to integrate x plus 2 divided by x plus 1 dx. x plus 2 by x plus 1 dx, and the points are given between 0 and 2. So it is a definite integral and you have to break it 0 and 2. Please see this question. X plus 2 divided by x plus 1 dx between the points 0 and 2. So we split. What I do is I write in this way, x by x plus 1 plus dx by x plus 1. See if you understand this step, how I have broken it up. X plus 2 I need, numerator is x plus 2. Here I have got x plus 1, plus 1, because dx by x plus 1 means 1. So x plus 1 plus 1. So I have got the numerator. Simple. So this breaks down into what? X plus 1 dx by x plus 1 plus dx by x plus 1. So x plus 1 cancels. So I am getting only dx. This only dx. Plus I get dx by x plus 1. Only dx means what? X. Integration of only dx is x. Plus dx x by 1. Integration means log x plus 1. So I get log x plus 1. Okay. Now the question is, we have to find out the limits are given 0 and 2. So I have to find this between 0 and 2. 0 and 2. So first let me take x equal to 2 and see what happens. So I will put x equal to 2 in this expression. So what I am getting is very simple. 2 plus log 2 plus 1, that is 3. And now I will put x equal to 0 because lower limit is 0. So if I put 0, I will get 0 here plus log 0 plus 1. That is 0 plus 1 is how much? 1. Now we know anything to the power 0 gives you 1. Anything to the power 0 gives you 1. So if you have a base 10 here and I am getting 1, that means 10 to the power 0 is 1. So this expression also becomes 0. So I am finally getting 2 plus log 3, which is the answer, because the rest of the expression becomes 0. Okay? So in this way we have solved question number 33. I go to the last few questions. I am now taking up question number 41. Okay. I am taking question number 41 now of exercise 8b. Okay. So we have to integrate x log x. Okay. Let me take 43 first. This seems to be an easy one. 43 I am taking first. 43. 43 is you have to integrate 3x square dx. Integrate 3x square dx between the limit 0 and 2. So the limits are given 0 and 2. We have to integrate 3x square dx. What I do is first I find out the value of the indefinite integral. I bring out 3 and this becomes x cubed by 3. Because x square means x to the power n and the formula is x to the power n plus 1 by n plus 1. So once you do it, 3 and 3 cancels out, you get x cubed. Now I have to find the limits 0 and 2. That means x cubed between the limits 0 and 2. Very simple. X cubed, if you put 0, the answer is 0. If you put x equal to 2, then you get 2 cubed. That is 8. And 0 to the power cube is 0. So the answer is 8 minus 0. So the answer is 8. This is the answer which I am getting. Question number 43 of the study material, exercise 8B. So we have done 43. Now we take up quickly 45. Okay, I'll take up 45. The last two questions we are taking up. 45 now. Keep a note of it, 45. The question is, we have to integrate x cube log x. X cube log x dx. Indefinite integral, it's not a definite integral. The limits are not given, so it is indefinite integral. X cube log x. This we have to integrate by using the integration by parts method. So what we do? We will take here log x, we will take as the second function and x cube as the first function. So u equal to x cube, v equal to log x. Okay? So we will carry out integration by parts and let us see what happens. Integration by parts means I will first keep u outside. So u will be outside. So x cube. I will first integrate log x. Log x dx. Okay? Otherwise, can we do one thing? Because we need to integrate this. Let's do one thing. In this case, let us take the other way around. Let us try and see, because this will take more time. Let us take, instead of taking u as x cube, let us just interchange and let me take log x as u and let me take x cube as v. That means in this case u will come out, so log x will be outside and I will integrate x cube first. So x cube dx I will integrate first, minus. Now I will take ddx of log x, ddx of log x, ddx of log x and multiply it with integration of x cube dx and the full will be integrated again. This is integration by parts formula. Critical, complex, but we have to learn and do it. So u here u I have taken as log x is kept outside, x cube is the second function, x cube dx I will do, then I will carry out differentiation of first function log x and then multiply it with x cube dx and the full will be integrated again. So let me see what I get. Log x into x4, x to the power 4 by 4 minus ddx of log x is 1 by x, 1 by x. X cube dx gives me, integration gives me x to the power 4 by 4 and the full I have to integrate again. This dx comes here. So what I get is 1 by 4, if I take out from here, I get x to the power 4 into log x minus, here I am getting 1 by 4 outside, x cancels, so I get x cube. So 1 by 4 is outside and I get x cube dx. That means I get 1 by 4 x to the power 4 log x minus 1 by 4 x cube dx. X cube dx gives me, if I remove the integration sign, it gives me x to the power n plus 1 by n plus 1. So it becomes x to the power 4 by 4 plus constant c. So the answer is 1 by 4 x to the power 4 log x minus x to the power 4 by 16 plus c. From here, of course, you can take 1 by 16 common and you can simplify the expression further. So this was number 45. We have done it. And let me take the last one, and this will be number 50, with which we complete the session. Okay. So I am taking the last question of the exercise 8B, number 50. let me attempt this question and let me see if I can completely solve it. Okay, so number 50 now. Number 50 is if f dot x equal to x minus 1. You have to find out the equation of the curve y equal to function of x passing through the point 1, 0. That means it will pass through the point x equal to 1, y equal to 0, and the tangent, equation of the tangent is given. F dot x means what? The differential coefficient. Curve, differential coefficient is the tangent. And I discussed about slope. So actually this is the equation of the slope of the curve. Okay? So we know y equal to x minus 1. So we have to find out the equation of the curve. As before, this is the last question of the exercise, I think. Just check 8b. Reasonably tough one, but let's see whether we can solve it. So y is equal to x minus 1. We integrate both the sides. Okay, so integration of y dy is equal to what we get is x minus 1 dx. So what we get here is x minus 1 dx means x dx minus dx. Minus 1 is like this, minus dx. X dx can be simplified. It becomes x square by 2 minus x. Dx integration is x plus the constant c. This is the equation of the curve we have got, but we have got c. This has to be eliminated. Now please note that this curve is passing through 1, 0. So for x equal to 1, y equal to 0. Let me check it once again. The point is 1, 0. Okay. That means if I put x equal to 1, y will be 0. So let me put x equal to 1 and y equal to 0 here. Y is 0. So left hand side becomes 0. Right hand side is x equal to 1. So it becomes 1 square. 1 square by 2 minus 1 plus c. That is 1 square by 2 is half minus 1 plus c equal to 0. So it becomes half minus 1 is how much? Half minus 1 is minus half. So c minus half equal to 0. So c is equal to half. C is equal to 1 by 2. This much we have got. If c equal to 1 by 2, then we will put c equal to 1 by 2 in this equation. So the equation will become y equal to x square by 2 minus x plus half. So this is the final answer, dear students. The equation of the curve, I think this is what we have to find out. The equation of the curve has to be found out. The equation of the curve is y equal to x square by 2 minus x plus half. And this is what we have done. We have first found out the integration of the given tangent. We have got the equation of the curve. Since the curve is passing through the point 1, 0, we are setting x equal to 1, y equal to 0. From there we get the value of c. C comes to half. We put c equal to half in the equation and solve it. With this, dear friends, we come to the end of the chapter, and we have done, I think, number of problems I have done is 1, 4, 9, 10, 11, 12, 18, 27, 28, 29, 33, 43, 45, 50. So altogether 12 to 13 problems from the exercise I have done, and equally I have taken equal intervals so that right from beginning till the end many of the problems have been solved. And before that also, during the exercise, during the examples I have taken, I think now the matter is clearer to you. Integral calculus, we have completed the basic formula. We discussed about the concept of integral calculus, antiderivative. We did the sum and addition part, integration by parts in details. We have also done the partial fractions. Thereafter we went into the definite integral, the concept, the function, area of the curve, bounded region, and then we did the rules concerning the definite integral. Thereafter we moved on to the exercise 8b and solved many of the problems. Dear students, with this we complete the chapter integral calculus, and with this incidentally also we are coming to the end of the business mathematics part of our syllabus. Next, of course, in the syllabus is the logical reasoning, and thereafter it will be statistics. Hope the journey so far has been good for you, and we have been able to interact and we have been able to take up many of the questions. Of course, hundreds of queries are coming. Given the time, you can easily understand it's impossible to provide each and every answer to each and every query, but I have tried to take as many queries as possible, often going beyond the schedule of 4 o'clock. It's now 5 minutes past 5, but I have tried to ensure that you follow, get the interest and get the confidence. Anyway, with this, thanks a lot for joining. I come to the end of this session of integral calculus, and next time, till the time we meet, take care and bye for now.